Welcome to our second presentation in basic statistics. So in this presentation, we'll delve more on the sampling techniques or methods which we previously introduced in the first or previous presentation. We'll also discuss the concept of variables and the types of variables we're going to encounter, and I will be providing you some examples using an actual study. So let's begin. The first sampling technique or method is what we call simple random sampling, or SRS. So this is a method in which we obtain a sample from a population where every member of the population has an equal chance of being selected. Let's have the first example. An institutional researcher is conducting a study of world campus students' attitudes toward community service. He takes a list of all 12,242 world campus students and uses a random number generator to select 30 students whom he contacts to complete the survey. So this researcher used SRS because participants were selected from the overall population in a way that each individual had an equal chance of being selected. So in the first example, you have 12,242 world campus students. That's your population. And the sample size determined prior to the survey was 30. And the tool used to generate the 30 students from, or out of the 12,242 students, was the number generator. See, this is available online and it's for free. So you can use this particular tool, number generator. Let's proceed to the second example. A student wants to learn more about the languages spoken in her town. She has access to the census forms submitted by all 3,500 households in her town. It would take too long for her to go through all 3,500 forms. So she uses a random number generator to select 100 households. She finds those 100 census forms and records data concerning the languages spoken in those households. Again, this is an example of a simple random sample simple random sampling method, because the sample of 100 households was selected in a way that each of the 3,500 households had an equal chance of being selected. If we go back to our previous discussion on bias, this is what would minimize bias. So for practicality's sake, if the population is too large, we just need to go for SRS, or simple random sampling. So we need to note at the bottom of the slide, we need to note that only a large sample size makes it likely that our sample is close to representative of the population. SRS is only applicable if we're dealing with large population. We're dealing with large population. Now, another sampling method is stratified sampling. So this still falls under inferential statistics. So stratified random sampling is a method of obtaining a sample from a population in which the population is divided into important subgroups, and then separate simple random samples are drawn from each subgroup, which are known as strata. So let's have an example for us to understand clearly what stratified sampling is. So the first example is attitudes toward community service. An institutional researcher is conducting a study of World Campus students' attitudes towards community service. He thinks that there may be a difference between students who are associates, bachelors, and graduate students. There are 917 World Campus Associates degree students. The researcher takes a simple random sample from that population. There are 4,819 World Campus Bachelor's degree students. The researcher then takes a simple random sample from that population. There are 4,560 World Campus graduate students. The researcher also takes a simple random sample from that population. Now, this is a stratified random sample because the population of all World Campus students was divided into 4 strata that the researcher believes could impact the responses to the survey. It is but logical to come up with a strata or a group representing that particular category where we will conduct our random sampling. Second example, acceptance of diversity. A researcher is interested in studying World War Campus students' perceptions of acceptance of diversity. She knows that of the 12,242 World Campus students, 27 identify as American Indian, Alaska Native, and 27 identify as Native Hawaiian, Pacific Islander. If she were to take a simple random sample from the population of all World Campus students, these groups would not likely be sufficiently represented. She chooses to use a stratified random sample with the strata being the different race or ethnicity groups. This ensures that there will be students from each group represented in her sample. Now, the third method or sampling method is what we call cluster sampling. So this is a method of selecting a sample from a population in which the population is divided into subgroups, that is, clusters. And a simple random sample of those subgroups is taken. All individuals within these clusters may be sampled, or a simple random sample may be taken from the selected clusters. Let's have an example. So, forestation and population density of forestation and flying squirrel. A researcher is studying the relationship between forestation density and flying squirrel population density in a certain or in counties of Estonia. I don't know how to properly pronounce these two names. His research requires him to travel to the locations that he is studying. If a simple random sample were used, he may have to travel to many different locations, which is not practical for him. Instead, he uses cluster sampling. There are 38 parishes in these counties. The researcher treats each county as a cluster. He randomly selects 8 parishes. Within each county, he takes a simple random sample of the townships that he will travel to for data collection. Now, to give you an actual example, here is something from a study I conducted back in 2015. The title of the study is Farmers' Entrepreneurial Competencies and its Impact on the SARIC program. SARIC being Sustainable Agriculture for Rural Income Growth, program implemented by the City Agriculture Office, where I'm working since 2011. Now, considering the sampling and data gathering instrument, the population of the respondents was 129. Farmers growing various crops such as rice, corn, and high value crops, specifically vegetables and cut flowers. So from the population, I determined the sample size. It's quite sufficient. The sample size is 95. And the data gathering instrument used was survey method with 2 questionnaires as my tools. The first questionnaire consists of the social demographic data of the respondents, farmer respondents, and the second is their personal entrepreneurial competencies, which I translated to Bicol. In the next slide, we have table 1, the distribution of respondents of the SARIC program. So as mentioned earlier, we have rice farmers, corn, vegetable, and cut flowers. So high value crops was divided into 2 strata, namely vegetable and cut flowers. So we have for rice 50, for corn 55, vegetable 3, and cut flowers 21. These are the number of farmers who availed during that span of time, who availed of agricultural loans in kind. So when you say in kind, these are in the form of fertilizer, pesticides, seeds, and others. So it's not in the form of cash. It's very clear that I used stratified random sampling. In the next presentation, I'll provide the steps or formula on how to determine the sample size given a specific population. Let's now go to variables. Variables are properties or characteristics of some event, object, or person that can take on different values or amounts. So in addition, constants do not vary. So variables may be independent or dependent, discrete or continuous, qualitative or quantitative. So what's the difference between independent and dependent variables? Now, when conducting research, experimenters often manipulate variables. For example, an experimenter might compare the effectiveness of 4 types of antidepressants. In this case, the variable is type of antidepressant. Now, when a variable is manipulated by an experimenter, it is called an independent variable. The experiment seeks to determine the effect of the independent variable on relief from depression. In this example, relief from depression is called a dependent variable. In general, this is what we should remember. The independent variable is manipulated by the experimenter, and its effects on the dependent variable are measured. Now, when we say qualitative and quantitative variables, qualitative variables are those that express a qualitative attribute, such as hair color, eye color, religion, favorite movie, gender, and so on. The values of a qualitative variable do not imply a numerical ordering. For example, values of the variable religion differ qualitatively. No ordering of religions is implied. Qualitative variables are also referred to as categorical variables. Now, when we say quantitative variables, these are those variables that are measured in terms of numbers. Some examples of quantitative variables are height, weight, and even shoe size. Now, what's the difference between discrete and continuous variables? Discrete variables can take only certain values. For example, a household could have 3 children or 6 children, but not 4.53 children. Continuous variables can take any value within the range of the scale. For example, time to respond to a question are continuous variables since the scale is continuous and not made up of discrete steps. Say, the response time could be 1.64 seconds. Now, here are some questions to clarify your understanding, specifically for variables. Now, which of the following are qualitative variables? 1. Height measured in number of feet. 2. Weight measured in number of kilograms. 3. Number of days it snowed. 4. Hair color. 5. Gender. 6. Average daily temperature. Next question. In an experiment on the effect of sleep on memory, the independent variable is 1. Number of hours of sleep. 2. Recall score on a memory test. 3. Gender of the subjects. 4. Gender of the experimenter. Just write your answers on a piece of paper or even email it to me. I'll provide the correct answers by the next presentation. Now, here are some tips on how to apply dependent variable and independent variables in research. First, the research title captures all the variables of the study. So it must capture all the variables of the study. The variables will then serve as the basis of the statement of the problem. Then the SOP, or the statement of the problem, and the review of related literature, or RRL, must also include all the variables. Lastly, the conceptual framework must reflect all variables of the study stated in the SOP. Here's an actual example from the same study we used earlier. The statement of the problem. We have an introductory statement or sentence. This study investigated farmers' entrepreneurial skills and its effect on the performance of the SARIG program implemented by the local government of Naga City. Specifically, this study sought to answer the following questions. First, what is the socio-demographic profile of the farmer beneficiaries of the SARIG program? Second, what are the entrepreneurial competencies of the farmer beneficiaries that respond to the SARIG program? What training did the SARIG farmer beneficiaries receive? Is there a relationship, this is the fourth, between the farmer's entrepreneurial competencies and the training received from the SARIG program? Fifth, what is the SARIG program's repayment rate? That's for the loan aspect of the program, because there's also a training component. Sixth, is there a relationship between farmers' entrepreneurial competencies and rate of repayment? And lastly, seventh, what interventions can be recommended to further strengthen the SARIG program? So in the next slide is the conceptual framework of the study itself. As you can observe, the first item there is farmer socio-demographic profile. This was stated in the SOP in the previous slide. So your farmer's socio-demographic profile is composed of the various items below. You have age, educational attainment, land area, number of years in farming, crops produced, average household monthly income, number of household members, and land ownership or tenure. The next item in the diagram is farmers training, or farmers field school as we call it. It's part of the Department of Agriculture's training for farmers. That's the technical term, or the right term for the trainings they provide to to the farmers of the province or even the region. And next is farmers' entrepreneurial skills, and lastly, SARIG repayment rate. Now, if you look at the lines connecting the items or the variables, the components, we don't have an arrow pointing to a specific item because we don't know yet which or what affects what. So it's safe not to use an arrow if it has not yet been established in terms of relationships, like would the farmer's social demographic profile have a relationship with the training, or even the entrepreneurial skills with the repayment rate, or even the repayment rate with the training, and so on. So if you're not sure of the relationship of any of the variables, or specifically what variable affects what variable, do not put or don't indicate any arrow pointing to a certain variable. So, but what we need to get from this particular slide is the appreciation of aligning your variables with your statement of the problem, with the review of related literature, until your conceptual framework. So we end here. I'll provide the next presentation hopefully next week. Thank you for listening.